Magandang araw! Sama-sama tayong matuto sa Teacher Sal Learning Resource Channel. Science 4, Quarter 1, Week 3. Our topic is all about materials and their uses. Classify materials at home and in school. Observe the books in the library. Observe goods or food products at home. How are books arranged in the library? How are the goods or food products arranged inside your food cabinet or refrigerator? How does it help when things are grouped properly at home? Matter has different physical and chemical properties, and these properties determine how it is classified, changed, and used. In the next phase of the lesson, you will learn more about other properties of matter and how to classify these materials according to these properties. Let's do an unscramble word game. First, its meaning. It is a measure of how quickly a specific material is capable of catching fire and burning. Unscrambled word number 1. The answer is flammability. These are waste products, such as packaging materials that can be slowly broken down into simple parts by chemical reactions or physical force. The unscrambled word number 2. The answer is degradable. Waste materials that can be broken down into simpler, non-toxic substances by microorganisms. The correct answer is biodegradable. For subtopic 1, flammability. Flammability is the ability of a material or substance to catch fire and burn easily when exposed to heat or flame. What happened when we burn a piece of paper? Did the material or paper catch fire and burn? Why or why not? Yes, because paper is dry and thin, making it flammable. What did you notice about how the paper reacted to the flame? It burned quickly and turned into ash. How do we know if a material is flammable or not? Flammable materials catch fire easily. We can test small samples safely or read warning labels. Recognizing the flammability of paper is important for fire prevention measures, especially in offices, schools, and homes. Example, a piece of wood from a tree. Wood is a natural material commonly used in construction and furniture making. Wood is flammable and can easily catch fire when exposed to heat or flame. It burns relatively slowly, producing heat and light. Understanding the flammability of wood is crucial for fire safety in buildings and forests. Example, a plastic drinking straw used in various products including packaging, utensils, and toys. Some types of plastic are flammable and can burn when exposed to fire or high temperatures. The flammability of plastic varies depending on its composition and additives. Awareness of the flammability of plastic is essential for fire safety in buildings, transportation, and waste management. Example, a cotton ball. Cotton is a natural fiber obtained from the cotton plant and is used in textiles, clothing, and medical supplies. Cotton is highly flammable and burns easily when ignited. It burns quickly and can produce a hot flame. Understanding the flammability of cotton is important for safety in clothing manufacturing, bedding materials, and medical applications. Next is a metal paper clip. Metals are solid materials characterized by their shiny appearance, conductivity, and strength. They include iron, aluminum, copper, and gold. Most metals are non-flammable and do not catch fire under normal conditions. They have high melting points and are not easily oxidized. Recognizing the non-flammability of metals is important for fire-resistant building materials, electrical wiring, and industrial applications. Your class will be divided into 4 groups. Each member of every group will decide on the specific role that you will play within your group. Team jobs. Along with each role are color-coded visors with their corresponding meaning. Manager red, speaker blue, director green, reports coordinator yellow. Each group will be given a copy of the activity titled Flame Test. Remind your teammates of their roles. Perform the activity as directed and answer the questions provided in the worksheet. Present your output in class. For the materials needed, safety goggles for each participant, candle or tea light, matches or a lighter, small samples of various materials, wood stick or toothpick, piece of paper, small piece of plastic, example plastic straw or bottle cap, metal paper clip, fireproof surface. Instructions: safety first. Before starting the activity, make sure all participants are wearing safety goggles and understand the importance of safety when dealing with fire. Work in group. Together with your teammates, perform the activity. Place the candle or tea light on a fireproof surface in a well-ventilated area. Ensure there are no flammable materials nearby. Conduct a flame test to observe how different materials react when exposed to fire. Start with the wood stick or toothpick. Hold one end of the stick with a pair of tongs or another safe tool. Light the other end of the stick with a match or lighter and observe how it burns. Notice the color of the flame and any smoke or residue produced. Repeat the process with the piece of paper and the small piece of plastic. Hold each material with tongs and carefully bring it close to the flame of the candle. Observe and compare how each material burns. What did you notice about how each material burned? The paper burned quickly, the wood burned slowly, the plastic melted and smelled, and the metal did not burn. Did all materials burn in the same way? No, the materials burn differently depending on what they were made of. Why do you think some materials burned while others did not? Some materials burned because they are flammable, while others did not because they resist fire. Why is it important to be cautious around flammable materials? It is important to be cautious around flammable materials because they can easily start dangerous fires. For Day 2, Subtopic 2, How Materials React with Other Materials. Materials can react with each other when they come into contact. This reaction can cause changes in the materials involved. Look how a baking soda reacts with vinegar. Did you observe any bubbles or other reactions? How did the baking soda and vinegar react with each other when combined? Vinegar is a weak acid commonly used in cooking and cleaning, while baking soda is a base commonly used in baking and household cleaning. When vinegar acetic acid is mixed with baking soda, sodium bicarbonate, a chemical reaction occurs, producing carbon dioxide, gas, water, and sodium acetate. This reaction is commonly used to create a foaming eruption resembling a volcano. Understanding the reaction between vinegar and baking soda demonstrates the concept of acid-base reactions and is commonly used in educational demonstrations and science experiments. Example, rusting of iron. Iron is a metal commonly used in construction and manufacturing. When iron comes into contact with oxygen and moisture in the air, it undergoes a chemical reaction known as oxidation. This results in the formation of iron oxide, also known as rust. Understanding the reaction between iron and oxygen is crucial for preventing corrosion in metal structures and equipment. Protective coatings and proper maintenance can help mitigate rusting. Example, foam production in a hydrogen peroxide and yeast experiment. Hydrogen peroxide is a chemical compound often used as a disinfectant, while yeast is a microorganism used in baking and in brewing. When hydrogen peroxide is mixed with yeast, the enzyme catalase in yeast catalyzes hydrogen peroxide's decomposition into water and oxygen gas. This reaction produces foam as a result of the release of oxygen gas bubbles. Understanding the reaction between hydrogen peroxide and yeast demonstrates the role of enzymes in catalyzing chemical reactions and is commonly used in educational experiments. Next is aluminum foil reacting with air. Aluminum is a lightweight metal commonly used in packaging, construction, and transportation. When aluminum comes into contact with oxygen in the air, it forms a thin layer of aluminum oxide on its surface. This layer acts as a protective barrier, preventing further oxidation. Understanding the reaction between aluminum and oxygen helps prevent corrosion and maintain the integrity of aluminum-based products, such as aluminum foil and aluminum alloys used in aircraft construction. Weathering of limestone by acid rain. Composed primarily of calcium carbonate. When limestone is exposed to acid rain, which contains sulfuric and nitric acids, it undergoes a chemical reaction called acid erosion. The acid reacts with the calcium carbonate in limestone, dissolving it and causing the rock to deteriorate over time. Understanding the reaction between acid rain and limestone highlights the environmental impact of air pollution on natural rock formations, historical monuments, and building materials. The reaction between acid rain and limestone highlights the environment impact of air pollution on natural landscapes and architectural heritage. It contributes to the degradation of limestone buildings, statues, and monuments, such as the limestone facades of historic buildings and sculptures in urban environments. Next example is tarnishing of silver jewelry. When silver comes into contact with sulfur compounds present in the air, water, or certain materials, it undergoes a chemical reaction called tarnishing. Understanding the reaction between silver and sulfur compounds helps explain the tarnishing process and guides the proper care and maintenance of silver objects and jewelry. Let's have activity number 2, Chemical Reactions Exploration. It is good for 30 minutes. For the objectives, observe and understand reactivity between different materials. Materials needed: safety goggles, several small containers or cups, various household materials for testing reactivity such as vinegar, baking soda, lemon juice, steel wool, aluminum foil, salt, water, food coloring, stirrers or spoons for mixing, paper towels or cloth for cleaning spills, pen and paper for recording observations. Safety first. Ensure all participants are wearing safety goggles and understand the importance of safety when handling chemicals. Adult supervision is necessary throughout the activity. Together with your teammates, perform the activity. Set up the containers or cups on a flat surface. Fill each container with a small amount of one of the testing materials. Example given: vinegar, lemon juice, or water. Add additional materials for testing reactivity, such as baking soda, salt, or food coloring to separate containers as needed. Mix different combinations of materials in the containers and observe what happens. For example, mix vinegar with baking soda and observe the reaction. Place a piece of steel wool in vinegar and note any changes over time. Mix lemon juice with baking soda and observe the reaction. Add salt to water and stir to see if it dissolves. Wrap a small piece of aluminum foil around a wooden stick and place it in vinegar to observe any reactions. Based on your observations, answer the following questions. What happened when you mixed certain materials together? Some mixtures made bubbles, fizzed, or changed color. Did you observe any bubbles, color changes, or other reactions? Yes, we saw bubbles, fizzing, and some color changes in the mixtures. How did the materials behave differently when combined with each other? Some reacted quickly and made bubbles, while others did not change at all. Can you identify any patterns or similarities in the reactions you observed? Vinegar and baking soda always caused a bubbly reaction. How might these reactions be useful in everyday life or in science? These reactions can help us in cleaning, cooking, or doing science experiments. For day 3, Subtopic 3, degradable or biodegradable. Degradable materials can break down into smaller pieces over time by chemical reactions or physical force, while biodegradable materials can be broken down by living organisms into simpler substances. Let's look how a certain material, like an apple core, can be decomposed. Describe the appearance of the apple core. Why is the apple core considered biodegradable? How do living organisms such as bacteria and fungi contribute to the biodegradation of such material? How does composting apple cores contribute to sustainable waste management? What environmental benefits result from returning nutrients to the soil through composting? The apple core is biodegradable, meaning it can be broken down by living organisms, such as bacteria and fungi, into simpler substances over time. When discarded in a natural environment, microbes in the soil break down the apple core through the process of decomposition. The organic matter in the apple core provides nutrients for soil organisms, contributing to soil health and fertility. Biodegradable materials like apple cores can be composted, returning nutrients to the soil and reducing waste sent to landfills. Here are degradable examples. Plastic straw. A plastic straw is a cylindrical tube made from plastic polymers, commonly used for drinking beverages. The plastic straw is degradable, meaning it can break down into smaller pieces over time when exposed to environmental factors such as sunlight, heat, and moisture. However, it does not break down into simpler substances through biological processes. Over time, exposure to sunlight or UV radiation and environmental stressors can cause the plastic straw to degrade physically, resulting in fragmentation into smaller plastic particles known as microplastics. These microplastics can persist in the environment for extended periods, posing risks to wildlife and ecosystems. Understanding the degradability of plastic straws highlights the environmental challenges associated with plastic pollution and the importance of reducing single-use plastic consumption. Next, example 2, polystyrene foam or styrofoam. Polystyrene foam is a lightweight plastic material commonly used for packaging and food containers. Polystyrene foam is degradable, meaning it can break down into smaller pieces over time when exposed to environmental factors such as sunlight, heat, and mechanical stress. Exposure to sunlight, UV radiation, and physical abrasion can cause polystyrene foam to degrade into smaller particles, known as microplastics. These microplastics can persist in the environment and pose risks to wildlife and ecosystems. Understanding the degradability of polystyrene foam highlights the environmental challenges associated with plastic pollution and the importance of reducing single-use plastic consumption. Example 3, nylon fishing line. Nylon fishing line is a synthetic polymer material used for fishing and other recreational activities. Nylon fishing line is degradable, meaning it can break down into smaller pieces over time under environmental conditions. Exposure to sunlight or UV radiation and mechanical stress can cause nylon fishing lines to degrade into smaller fragments. These fragments can persist in the environment and pose risks to aquatic life, such as entanglement and ingestion. Recognizing the degradability of nylon fishing lines underscores the importance of proper disposal practices and the use of eco-friendly alternatives to reduce environmental harm. Here are biodegradable examples. Paper towel. A paper towel is an absorbent sheet made from paper pulp, commonly used for cleaning and wiping surfaces. The paper towel is biodegradable, meaning it can be broken down by microorganisms into simpler organic compounds over time. When discarded in a compost pile or natural environment, microorganisms such as bacteria and fungi feed on the paper towel's cellulose fibers through the process of microbial decomposition. This process converts the paper towel into humus, a nutrient-rich organic material that enriches soil fertility. Biodegradable materials like paper towels can be composted, diverting organic waste from landfills and contributing to soil health and sustainable waste management practices. Next is banana peel. A banana peel is the outer protective covering of a banana fruit. It is biodegradable, meaning microorganisms can break down the peel into simpler organic compounds over time. When discarded in a natural environment, microbes in the soil decompose the peel through microbial degradation. The organic matter in the banana peel provides nutrients for soil organisms, contributing to soil health and fertility. Biodegradable materials like banana peels can be composted, returning nutrients to the soil and reducing waste sent to landfills. Next is cotton fabric. Cotton fabric is a natural textile material made from the fibers of the cotton plant. Cotton fabric is biodegradable, meaning it can be broken down by microorganisms into simpler organic compounds over time. When discarded in a natural environment, Microbes in the soil decompose the cotton fabric through microbial degradation. The organic matter in the cotton fabric provides nutrients for soil organisms, contributing to soil health and fertility. Biodegradable materials like cotton fabric can be composted or naturally degraded, minimizing environmental impact and promoting sustainable waste management practices. Let's have activity number 3, exploring degradable and biodegradable materials. It is good for 15 minutes. Objective: identify materials that are degradable and biodegradable. Here are materials needed: samples of degradable materials, plastic drinking straws, polystyrene foam. Sample of biodegradable materials, apple cores, cotton balls. Clear containers or jars, water, notebook and pen for recording. Safety gloves. For the instructions, work in group. Together with your teammates, perform the activity. Place the clear containers or jars on the table. Separate the samples of degradable and biodegradable materials into 2 groups. Observe each sample and describe its appearance and composition. Based on your prior knowledge, predict whether each sample is degradable, biodegradable, or neither. Fill each container with water, covering the samples inside. Carefully place one sample from each group, degradable and biodegradable, into separate containers. Record your observations over a designated period. Example given, 24 hours. Note any changes they observe in the samples, such as changes in texture, appearance, or size. Did any of the samples change over time? If so, how? Yes, the apple core became soft and started to break down, but the straw and styrofoam did not change. Were there any differences between the degradable and biodegradable samples? Yes, the biodegradable ones started to rot, while the degradable ones stayed the same. What factors might have contributed to the observed changes? Water, air, and bacteria help the biodegradable items to break down. How do these observations relate to the concepts of degradability and biodegradability? Biodegradable materials break down naturally, but degradable ones do not break down easily or quickly. Outline in the concept map what you have learned in the lesson. Utilize the given concept map below. Under chemical properties of materials, we have flammability, reactivity with other materials, and degradable and biodegradable. Flammability or burnability. Some materials can catch fire and burn when exposed to heat or flame. For example, wood, paper, and certain types of plastics can burn. This burning process is a chemical reaction where the material combines with oxygen in the air to produce heat and light. It's important to be cautious around flammable materials and to never play with fire. Reactivity with other materials. Materials can react with each other when they come into contact. This reaction can cause changes in the materials involved. For instance, when iron, a metal, reacts with oxygen and moisture in the air, it forms rust. Similarly, when vinegar, an acid, is mixed with baking soda, a base, it produces bubbles of carbon dioxide gas. Understanding these reactions helps us predict how materials will behave when combined. Degradability and biodegradability. Materials can break down or decompose over time due to various factors such as exposure to sunlight, air, water, or microorganisms like bacteria and fungi. Degradable materials eventually break down into smaller pieces, while living organisms can break down biodegradable materials into simpler substances. For example, food scraps, paper, and certain types of plastics are biodegradable, meaning they can be broken down naturally by bacteria and other organisms in the environment. Which of the following best describes flammability? A. The ability of a material to dissolve in water. B. The ease with which a material can catch fire and burn. C. The tendency of a material to react with oxygen in the air. D. The ability of a material to conduct electricity. You're right, the correct answer is letter B. What is an example of a flammable material? A. Glass. B. Metal. C. Paper. D. Rock. Very good. The correct answer is letter C. Paper. When iron reacts with oxygen and moisture in the air, what does it form? A. Aluminum oxide. B. Rust. C. Carbon dioxide. D. Hydrogen gas. Very good. It's letter B. Rust. Which of the following materials is biodegradable? Plastic drinking straw, nylon fishing line, banana peel, or styrofoam packaging? You're right, it's letter C, banana peel. What happens to a banana peel when it is discarded in a natural environment? It remains unchanged indefinitely. It decomposes into simpler organic compounds. It reacts with other materials to form new substances. It breaks down into smaller pieces over time. You're right, the correct answer is letter B. It decomposes into simpler organic compounds. Sarah wants to dispose of her plastic water bottle. Plastic is harmful to the environment, so she wants to choose a more eco-friendly option. Which of the following materials should Sarah choose if she wants a biodegradable option? Plastic water bottle, glass bottle, aluminum can, biodegradable paper cup. You're right, the correct answer is biodegradable paper cup. Tom is conducting an experiment in his science class. He wants to observe how different materials react with vinegar. Which of the following materials is most likely to produce bubbles when mixed with vinegar? Metal paper clip, plastic drinking straw, glass marble, or cotton ball? You're right, it is letter D, cotton ball. Emily is decorating her room and wants to hang up some pictures using metal nails. She is worried about the nails rusting over time. What can Emily do to prevent the nails from rusting? Paint the nails with a waterproof sealant. Keep the room temperature low to slow down the rusting process. Use plastic nails instead of metal nails. Nothing, as rusting is inevitable for metal nails. Very good. The correct answer is letter A. David is helping his mom in the kitchen. She accidentally spills some lemon juice on the marble countertop. What is likely to happen to the marble over time? The marble will remain unchanged. The marble will dissolve and disappear. The marble will develop stains and discoloration. The marble will react with the lemon juice to form a new substance. You're right, the correct answer is letter C. For number 10, Anna is packing her lunch for school. She wants to use a material for her sandwich wrapper that will break down easily when discarded. Which of the following materials should Anna choose? Plastic cling film, aluminum foil, biodegradable wax paper, styrofoam container. It's letter C, biodegradable wax paper. For your homework, Eco Discovery Quest. Embark on a quest to find 2 items in your home that hold secrets of nature's recycling magic. For each item, decide whether it possesses the power to break down over time, which is degradable, transform with the help of nature's living creatures, biodegradable, or stand resilient against the forces of time, non degradable. Write down your findings in your adventures journal. Imagine the story behind each item's magical abilities and share a tale of their adventures in your journal. For submission, craft your responses on parchment paper or type them on a mystical device. Present your enchanted findings with sketches, spells, and tales of wonder.